So remember, in chapter 19, we've been covering amines. Okay. And last class we covered how to name them, okay, and some of the properties. Okay. If you weren't here for last class, make sure you take a look online to watch that video. Okay. And make sure it's on there. Some of you had some difficulty there. Okay, well, the main property of amines, remember they not only smell bad, smell like fish, okay, but they have this important property that they are bases. Okay? So remember, a typical amine might look like that. Okay, where you have an alkyl group, carbon group on nitrogen. It's the lone pair that is making the amine basing. Okay? So what we want to do is look at the basicity of amines in a little bit more detail today, okay? And see what makes an amine more basic or what makes it less basic, okay? And the way we're going to do that is by looking at what are called the pKb values, okay? So to get an idea how pKb works, let's look at its relative, the pKa. Remember, for example, if we looked at the pKa, we're looking at acids of some type, and so HCl has a pKa of -7. But if you looked at the pKa of, say, hydrofluoric acid, it would come out to a value of something like 3.2. Okay? Which of those two was the stronger acid? It's always the one that has what? The smaller number. Okay? So the smaller that number was, the stronger that acid was. Okay? The same principle holds for pKb. Okay? That the smaller the pKb is, guess what? The stronger the base. Okay? So it's the exact same principle, except we're looking at bases. Okay? So that's what we want to do, is look at a series of amines and their pKb values and look for any trends, any predictions that we can make. Okay? So let's start that by looking over here. And what we'll do is we'll start with this molecule, NH3. Remember the name of that? Ammonia. Ammonia. Ammonia is where the amines are derived from. Well, ammonia has a pKb of 4.74. Okay? So we will let that be our reference value. Okay? Of 4.74. Okay? So, in comparison to ammonia, let's look first of all at primary amines. Okay? So, one example of a primary amine is this one here, methylamine. Okay, and it has a pKb of 3.36. Okay. So what can you say about its basicity compared to ammonia? It's a stronger base, okay? Not a super stronger base, but it is a stronger base, okay? All right. Wonder why it's a stronger base than ammonia. What must it have to do with? Yeah, this methyl group. Remember what a methyl group was when we covered benzene chemistry? Was it an electron pusher or a puller? Was it a donator or a withdrawer? Did it activate the ring or deactivate the ring? Okay, it activated the ring, so it was what? A donator. Was a donator. Okay? So CH3 is pushing electrons toward the nitrogen. And if it's pushing it toward the nitrogen, it's pushing it all the way to the lone pair. See that? So the lone pair, what's it wanting to do? It's wanting to do what? To leave, to attack something. See that? So this CH3 has made this more basic by kind of pushing it out to want to attack an acid. Okay? This one here doesn't have any pushers on it, so it's less basic. Okay? Let's compare to another amine here. Here's a primary amine, cyclohexylamine, and it has a pKb of 3.33. What might you say about this one compared to that? Just a little stronger, not much at all, is it? Yeah, just a little stronger. But what could you say about the cyclohexane group versus the methyl? It's a little stronger donator, isn't it? Okay, not by much, but it's just a little bit there. Okay, so that's how we can use pKb's to see what's a stronger donator and so on. Okay. All right, let's look at another comparison. Let's now look at secondary amines. Remember, secondary amines had two alkyl groups on there. So let's make this one here, where we have two methyl groups. Any predictions? Think that'll be a stronger or weaker base?
Stronger.
Why stronger? Because I have two donors. Yeah, so that makes sense. So I have two donors, so it should be stronger. And it comes out to 3.28. So you were right. Okay? So I have an extra donor, and so it makes it a stronger base. Okay? So we can say that secondary amines are stronger bases than primary amines. Any questions on that there? All right. Well, let's go out to the next one. And look at tertiary amines. Okay, so now we'll have 3 alkyl groups. So let's stay with our analogy here and put on 3 methyl groups. So in this case, having trimethylamine. Okay. Just to note that your quiz this week, including today, will be on amines. Okay, we'll have a lot of naming of amines on there, so you want to review that. And you'll have one question about basicity of amines, so make sure to follow along. What would you predict this tertiary amine to be? Stronger or weaker than the secondary? Expect it to be stronger, because now I got 3 donating groups, don't you? Well, let's see what the evidence gives us. The data comes out to be 4.26. So it goes against our thinking. There was nothing wrong with our thinking, okay? But our thinking was wrong in accordance with facts. Okay? Wonder why that's the case. Okay, well, there's no hydrogen there, but that's not making it there, the difference. Anybody else?
Is it because it's creating sterics?
Okay, now with these 3 CH3s, I've got all this steric bulk here to make it a what? A bulky base. See that? So this here is a bulky base. So the sterics are preventing that lone pair from getting out to attack something. And so the basicity goes down. Okay? It's still more basic, interestingly enough, than ammonia, isn't it? Okay? Even though ammonia has 3 small hydrogens. Okay? So it's kind of balancing, because you got those donors that are making it push, but it's still not less basic than that, even though it's bulky. Okay? So this is how you can use data to try to formulate theories. See that? You can predict all you want, but if your prediction is wrong against the facts that you find out, then you have to reformulate the theory. Okay? That's what we did. Okay? So remember the trend. Secondary amines are stronger than primary amines, but tertiary is weaker than both primary and secondary amines. Okay? Any questions on that? Okay. Let's look at another example. Let's look at this molecule here. Anybody remember the name of that molecule? No, pyridine. Pyridine had the nitrogen in the ring. This is what?
Aniline.
Aniline. Okay, so aniline is an amine. Okay, nitrogen with a carbon on it. What would you predict the basicity of aniline to be with these other amines we looked at? Do you think it might be stronger or weaker than what we just looked at? Okay. Well, if you put it in the measuring device, it comes out to be 9.4. So what does that tell you? Much weaker. Opposite. Okay? So it's turning out to be a much weaker base than these things, even the tertiary amines. Any idea as to why that's the case? What can I draw for that? Resonance. See that? The lone pair next to a pi bond, puts that in for resonance. See that? So it's going in instead of going out. It's doing the exact opposite of what these pushers are doing. See that? Okay? So this is going into the ring. So it's not as available for attacking. Okay? So that's what the benzene ring does. It invites resonance. Okay? Or another way to state it is that this lone pair is resonance stabilized by the ring. Okay. Okay. Any questions on aniline, of why it becomes a weaker base? Okay. So see how we're using all our theory that we've been learning, resonance theory, donation theory, in correlation with basicity. Okay. Well, let's take aniline. And now, let's put on a nitro group. What do you think that's going to do to the basicity? What's NO2? So what does that mean? Is it pushing or pulling? Pulling. Okay. So it's even going to reach all the way to the lone pair and help pull that out. So you think it'll be higher or lower than 9.4?
Lower.
It'll be much higher. Why would you say lower?
You say it's pulling it in?
Why would you say lower? Goes up to 13. Okay, so the benzene ring's already pulling on it, but now I got a puller, extra puller, so it's pulling it even more. Okay. Now, if I would have had an electron donator on the ring, then it would have made it a smaller value or more basic. Okay. See if they have an example of that. There's a methoxy group. Remember, that's a activator, a donating group. So that's pushing there. So So the basicity should be more, and it drops down to 8.6. Okay, so it's a stronger base than aniline. Okay, so donors make it stronger, the withdrawer makes it a weaker base. Okay, it's the same principle that we started with. Okay, any questions on how aniline works? Any questions there?
Did you get that PKB for that little molecule?
13. Okay. Let's look at another one here. We learned this one in last class, roll. What do you think about the basicity of that lone pair? Yeah, maybe even compare it to aniline. Do you think it'll be a stronger or weaker base? Okay, so look at the lone pair. Is there any kind of stabilization here? Yeah. What's it helping the ring to be? Chapter 16, aromatic. Very good. Okay. So it's contributing to make the ring aromatic. So do you think it wants to donate itself? No. So this will be an even weaker base. And this comes out to about 15. Okay? So remember, the less available it is, the less basic it is. Okay? So here it was being tied up into resonance. Here it's being tied up into not only resonance, but also aromaticity, which is very stable. It doesn't want to break that. See, if this were to attack, it would lose the aromaticity, and it doesn't want to do that. Okay. Any questions in aniline or parole? Okay, see how all this theory we've been learning is coming back in a summary form. Okay, what about this one here? We'll learn later the name of that, acetonitrile. But here, the lone pair is on this nitrogen. What do you think about that? Do you think that'll be a strong base or not? Well, the way to view that is this nitrogen is sp hybridized, okay? So that means that this lone pair is in an sp orbital, okay? Taking notes? Perfect. Notes.
I'm gonna get all on, because I missed the first beginning, so I'm gonna get all on for somebody.
So if I have it in a sp orbital, okay, what's that going to do? Do you think it's going to restrict it or make it more available? Okay, you're right, it will restrict it. Any idea why? A little technical. Okay. Here, this has lots of S character. Okay, compared to SP3 or SP2, here is 50% S character. And the more S character I am, the closer to the nucleus I am. Remember that the nucleus is positively charged, so those electrons will be what? Very glued to the nucleus, so they won't be as available, okay? Whereas regular amines are sp3, and sp3 does not have as much S character as sp. So these are not as glued to the nucleus as these are. So what do you think that's going to do to the pKb? Make it much higher. Okay. Takes it up to 24. 24. Okay. So if I have an sp lone pair on nitrogen, it's an even weaker base than this aromatic lone pair. Interesting. Okay. Okay. So any questions on the basicity of amines? Now, if you compare that to pyridine, okay, there's pyridine. It has a pKb of 8.8. See why there's a big jump? This nitrogen is what? An sp2 nitrogen. And it's not involved in any resonance. So this will be much more available than that there. Okay? Compared all the way to this one, where now this is an sp3 nitrogen. This goes down to 2.2. So it's an even stronger base because I have even less S character here. Okay. So you see the hybridization effect. sp weaker, then sp2, then sp3. Okay, so we have a lot of comparisons that we were looking at today. We were looking at primary, secondary, tertiary amines, which you caught on very easily. We were looking at resonance stabilization. And then lastly, we were looking at hybridization comparisons. Any questions on this? A lot of questions there.
Will these be given to us or?
PKB? Oh, yeah, I'd give it to you. Okay. Only way I wouldn't give it to you is if I just say I gave you that and that, for example, and say which is the stronger base. I wouldn't be asking for the PKB value, but I would just say which is stronger. Or I could say which of these two has the smaller PKB. Okay. Anything else? Okay. All right, so that's what we're going to look at the rest of this chapter is the chemistry of amines being bases. Okay, so let's look at one use of this. let's look at amines being phase transfer habits. Okay.